Hello everyone, so it's good to see you all again. I'm Natasha and welcome back. So today we're going to continue our fifth chapter. It's complex numbers and quadratic equations. So in today's video, we'll be discussing about the amplitude, or we can say the argument of a complex number. Okay, sounds interesting. So in the previous video, we discussed about the polar form of complex numbers. And in this video, we'll be solving a question on it. So we'll take a question that will be related to the polar form of the complex number. Okay, so in this video, we'll discuss about the amplitude of the complex number z. So let's get started. Okay. So let me first write the heading and then we'll just continue. Okay, so what's our today's topic? It is the argument, or you can even say the amplitude. Both are same. Argument of z. Like z is not having an argument with someone, okay? It's a complex number, so I'm just exactly saying the amplitude of z, okay? So take it as a different argument from the common word argument that we use. Okay, so whatever argument of z, right? So let's say this complex number z is equal to x plus iota y, right? Okay, so let's see it in the graph too. Or I can just say the plane. It looks like the marker's a little light. I'm gonna just make it again. Okay, whatever. Yeah, so here we have our small plane which is not flying. Okay, so this is going to be our imaginary axis. Yeah, and this is going to be the real axis, okay? Okay, right? Yeah, so this is going to be our imaginary axis and this is going to be the real axis, and this is going to be the origin O, okay? So let's take a point P, which is representing this complex number z, okay? Yeah, so let's say this point P is right here, and if I'm going to talk about the coordinates, that's going to be x and y, right? Yeah, according to this. Okay, so and we know something already that it's really looking like a lightning bolt, right? Zigzag. Okay, I'm just gonna, make it again. It's just because of the marker. I think it's a little light, so I'm just gonna make it again. I'm gonna write it again. Okay. This time I'll make sure to make a straight line. Let's say this. Here it is P point, X and Y. Okay, so, okay, let's just forget about it. That's all I can do. Yeah, so this line OP, which is in the positive direction, what do we call it? We call it as the modulus, right? This line OP, right? We already know that, which we can say the modulus of Z. So what's going to be the modulus of z? So we have our modulus of z as the x squared, root x squared plus y squared, right? Yeah. So what we can see here is, so this is going to be our r, okay? R, which is equal to mod z, and mod z is equal to root x squared plus y squared, right? This is clear, okay? So there's nothing to be confused, so it's totally clear to us. Okay, so this argument thing is related to, the modulus of a complex number. So let's discuss how. And it's even related to the polar form, the polar representation. So actually it comes in the polar representation of complex numbers. Okay, yeah. So we have taken a point P, and the coordinates, which are x and y, is the modulus of z, the complex number z, and the angle theta. Okay, now what is this angle theta? Okay, this angle theta is just going to be right here, okay? Or angle theta, right? Okay, and let's make a parallelogram right here, okay? So if I'm going to talk about it, this axis is going to be x, and this one's going to be y, right? This is exactly clear? Okay. So now what is this anti-clockwise, if you have really heard about this topic? What is this anti-clockwise and clockwise? So we need to discuss this, okay? Okay, so like there's a line, there's something that is going, just in an anti-clockwise direction, okay? It can even go in a clockwise direction, but, about this anti-clockwise and clockwise directions, like we'll be discussing about them in a, principal argument of complex numbers. So one thing I want to say, that there's literally like this principal argument and this amplitude, or I can say the argument, they both are, different. So they have they have a difference, okay? They're not exactly the same, okay? Okay, so, let's move on. So, what I want to say is, the point P, which is representing this complex number, and, then the angle theta, that, that line OP is making with the real axis, taken in anti-clockwise direction, is known as the argument or amplitude of what? Of this z, okay? This complex number z, okay? Okay, I hope this is clear to you. So how about writing this statement too? So I'm just going to write it in a really small way. So, but before that, just wait a second. Let me check the camera, because I think it's not clear. So let me check. Just wait a second. It will take just a few seconds, okay? Then we'll continue. Okay, so it's absolutely clear, and let's continue. Okay, so let's say what I used is I used the point, okay? That's clear. So I'm just gonna write it in a really simple way. So the R, okay, remember this R is the length, okay? Length, which R is equal to mod Z, and which is equal to root x squared plus y squared, okay? Yeah, so this R, the mod Z, this R, which is just right here, okay? Which is just right here is, let's say this R, which is equal to mod Z, is equal to root x squared plus y squared, is the modulus of Z and theta. And one more thing that we can see is, it's kind of having a different kind of thing, related to the direction, okay? So we need to understand that thing, okay? So let me repeat it again. So, this R, which is the modulus of Z and theta, is known as the argument or the amplitude of Z, okay? Right? So let me write it. Z and theta is known as the argument or amplitude of complex number Z. So what I'll say of complex number z. Okay, so complex number z, right? Okay, so how about just let me just erase it. Okay. To make it short, because we already know that this z is a complex number, so what I'm just directly going to write is the argument or amplitude of z, which is denoted by, guess what? Like, how to denote it? So, like, how do we represent it? How do we denote it? So, it is denoted by this ARG, or maybe I can say this arch. I don't know, like, what to say, but this means the argument, okay? ARG, this means the argument, okay, of z, okay? Z is the complex number that we're here, using. So it is denoted by, the ARG, or the argument of z, right? Okay, it's totally clear, right? Let's move on. Okay, so is this clear? Then if it is, then let's continue. Okay. So about this anti-clockwise direction thing, we'll discuss it soon, but not in this video. So what you can see in the plane, there's the graph, in the diagram. If I'm going to talk about this, like, what's going to be the tan theta? Okay, what's going to be the tan theta? Okay, what we can see here is we have this graph, this plane, in which we have two axes, real axis and imaginary axis. Real axis for x, imaginary axis for y. We already know that, so I'm not going to repeat it again and again and again. So, what we saw here was x and y. So, as far as and maybe you too, so as far as we remember, we discussed how to solve this, how to find out this tan theta, in physics, or, in the chapter 4, right? I'm not sure. Was it chapter 3 or 4? I'm not exactly sure. Okay, maybe, yeah, it was actually fourth chapter, motion and plane. So, what we discussed there was, this tan theta is going to be equal to the y, which is here, by x, okay? Right? Is this clear? Yes. If it is, then let's move on. Okay, if I'm going to ask it, like, what's going to be the value of this y? Okay, so, let's just use our mind. So, what we can see according to the complex number topic, okay? So, let's forget about the physics thing. Okay, so y, which is the imaginary axis. How can we, like, okay, if I'm going to talk about this part, x plus iota y. This x will be the real part of z. This y will be the imaginary part of z. So, did you get that what I'm trying to say? I'm trying to say that this y is going to be the imaginary part of z, right? According to the complex number. So, this y is equal to, is going to be, imaginary part of z by x is going to be the real part of z, okay? So, tan theta is equal to the imaginary part of z by the real part of z, okay? So, suppose I have, let's say I have 2, okay, at the place of x. And, no, okay, let's change it, okay, let's change it. How about I say, okay. Okay, so let's say that this x is 4, okay, let's say. And this y is 2, right? Yeah. So, if my x is 4 and y is 2, then what is it gonna be? What's the value of y? 2 by 4, right? If I'm gonna cancel it, then what am I gonna get? 2 by 4. Okay, so this 2 by 4 is actually going to be, okay, it's gonna be half, 1 by 2, right? Okay, so one thing I want to tell you that, like I took the values, I took the constants at the place of these things. So what we can see here is, if I just took a value and what I got, the answer was 1 by 2. So, this is how, like, we're usually gonna solve it, okay? So there's no need to write this thing. That was just, an example to tell you that. What if there would have been options at that place? Okay, so one thing that I wanted to tell you is that this argument thing lies between 0 to 2 pi, okay? Lies between 0 to 2 pi. Okay. If we're gonna have a look at the trigonometric functions, like we haven't discussed about the third chapter, but we'll soon discuss it. I just, skipped it, so, but, we'll soon discuss it. So maybe, I think maybe right after this chapter. Okay, so whatever, but, this, okay, so according to the trigonometric, what was it? This pi is going to be equal to 180 degree. So this 2 pi will be 360 degree, right? 2 into 180 will be, 360, right? So 2 into 180 is gonna be 360. So one thing, here I'm gonna tell you. If we're gonna have a look at the graph, we can see here is this is our first quadrant, this is our second quadrant, this is our third and the fourth quadrant. Okay, right? And what we can see is here 2 pi. So here what is it going to be? 90 degree, right? Here 180 and then 240 and then 360. Am I right? There's a third one. Okay, whatever, but I think it's absolutely right. Okay, yeah, it's absolutely right. Okay, yeah, it is. Okay, so what we can see is the first is for 90 degree, if I'm gonna have a look at according to, if I'm gonna have a look at it according to the earlier classes, so what's it gonna be? The first quadrant will be for the 90 degree, second will be for 180 degree, third 240. Actually, I'm not sure about this one. But I think that it's 240, right? Okay, and the fourth, it's for the 360 degree, right? So this is like clear, and we'll discuss something different in the principal argument, and principal argument is related to all this thing, So, we'll discuss about it in the next video. So for now, we have a question to discuss, okay? And, as I told you, in the beginning, right? So let's do this question, okay? Yeah, let's do this question. So write z is equal to 1. Let's say we have, okay, so question, okay, let's say 3 plus 3 iota. Okay, I'm getting confused. Should I take, okay, I'm going to take 2 values, okay, 1 and 3, okay? Let me write again. Let me just write it again. Yeah. So what I'm saying is, okay, let me write it again. Okay, no need to get confused. Okay, so this z is equal to root 3 plus iota. Okay, so write this complex number in the polar form, okay? In the polar form. Okay, so this is a question, right? Okay, so let's solve it. So the solution is going to be, okay, if I'm going to have a look at the x, okay, let's say this is x and this is going to be y, okay? Right? Yeah. So if I'm going to say that what's going to be my root 3, which is, you know, the x-axis. So it's going to be r cos theta, right? And if I'm going to talk about this iota, which is going to be y, so this iota is going to be equal to, will be equal to this r sine theta, right? As we discussed this thing in, the polar form of complex number. So at the place of iota, I can also write 1. So why don't we just write 1 here, okay? So that, we won't get confused. Well, I don't think there's any need to get confused. Okay, so 1 is equal to r sine theta. Okay, this is clear. Okay, so let's move on to our next step. So as we have written r here, so let's talk about this r, okay? Okay, so what's going to be our r? So first of all, we have to find that what's going to be our r, like what's going to be the value of r. R is equal to mod z, and our z is, root 3 plus iota. So it's going to be in root 3 plus 1, right? Right? Isn't it? Isn't it? Okay. If yes, then let's move on, okay? So this root 3 plus 1 is going to be 2. Like, can you even imagine, like, how is it going to be 2? Right? How is it going to be 2? Okay. So, what we had, here was, let me, just write it again, okay? Okay. Yeah. So, what we had here, there was already a root given to us here, right? So don't forget this root, okay? So that you won't get confused. So after, the small z is going to be root, and in the root we'll already have a root, 3 plus 1, okay? Right? Yeah. And so, after just, this removing this square root we have, so what we'll get is root 3 plus 1, right? 1 will be as, as it is, just the same. So this is how, through that way I got this answer 2, okay? Okay, so I just wrote it like in the simplest way, okay? Don't forget this root, okay. Okay, so let's move on. So now we need to find our cos theta and sin theta, okay? So through that way, we'll be easily able to find the polar form of what? The complex number z, of course. Okay, so what's going to be our sin theta? And our, cos theta. Okay, sin theta is going to be, okay, let's first talk about this theta, okay? Okay, so according to the values we're having, which is root 3 and 1, okay? Right? Yeah. So according to, these values, our sin theta is going to be 1 by 2. Sin theta is going to be 1 by 2, and cos theta is going to be root 3 by 2. Okay. Do you know that the 30 degree, cos 30 degree is going to be root 3 by 2? Right? Am I wrong? That's like your choice. Well, I don't think so, because as far as I know, this cos 30 degree is equal to root 3 by 2, right? So, that's basically not related to that too much. So, what I just simply did, like to find, whenever we're finding the sine theta and the cos theta, it's really easy. It's just, some kind of a beginner thing. So, I don't think there's any need to discuss these things, right? Okay, so let's move on. So, we have got our value here, okay? One thing we need to remember is that our theta is going to be, what is it going to be? It's going to be pi by 6. Our theta is going to be pi by 6. Okay? Okay. So, what we can see is, our theta is equal to pi by 6. One thing, in this question, like there's pi and all these things. So, second thing, I'm going to say that, it's related to the principal argument. So, let's discuss it a little, okay? A little. Just a small graph here. Or maybe if this is not going to be clear to us, then we'll discuss the same question in the next video, like whenever we'll discuss the principal arguments. Okay, so for now, let's just continue. Okay, so what we'll have is, root 3 is our x-axis. Remember, here we have our x-axis, y, negative x, negative y. Okay, right? Okay, x is root 3, okay? Root 3. 1 is the sine theta, okay? This is clear? Is this clear? Okay. So, sine theta was 1 by 2. Okay, if I'm going to talk about the sine theta, then sine theta is going to be just like this way, right? Right? So, this is how I got this 1 by 2. And cos theta was here, root 3 by 2. Okay, so we here know that this, in denominator, there's 2 coming in both. So, that was just really an easy way. And, we use our sense of humor. Well, there's nothing to say about sense of humor. So, this root 3 by 2, so this is how we got this cos theta is equal to root 3 by 2 and sine theta 1 by 2, okay? This is clear. Till here, it's clear. So let's see how this, this theta is equal to pi by 6. Okay, so as far as we know, this value of pi is going to be, okay, so let's just, forget about this question. What's the value of pi? It's going to be 180 degree, right? Okay, if I'm going to talk about it in normal ways, like what's going to be the pi? It's going to be 3.14. Rather than that, it's going to be 22 by 7, right? But forget about this, okay? Forget about this. So, our pi will be 180. So, I'm just doing some things, but it's not exactly related to it because we'll be not exactly solving it. So, we just have to, write this complex number in the polar form. That's it. Pi, which is going to be 100 by 6. If I'm going to cancel it, by 2 into 3, and there's 2, 90, and 3 plus 1 and 30. Okay, so here I got 30. So our theta is equal to 30 degree. Okay, if I'm going to cancel it, then I'm going to get this answer 30 degree. So in the more detail, like in degrees, if I'm going to talk about it, rather than the radian, our theta is going to be equal to 30 degree if I'm going to put the value of 180 degree at the place of pi. But we're not going to do that. Okay? We're not going to do that. Okay? So what we can see here is we understood all these things, okay? But actually, why I didn't move further, there, because we haven't discussed the principal argument. So I thought, after discussing the principal argument, that will be like more understandable. So before that, let's just directly write it. So our theta is equal to pi by 6. And if I'm going to talk about the value of z, so let's write it polar form. Therefore, the polar form of z is what is it going to be? What is it going to be? Z is going to be equal to, okay. It's going to be equal to, Okay, one thing, let's just remember the polar form, okay? Polar form. In the polar form, we have our cos theta and sine theta. So, as we remember the formula, there was such kind of a formula there. So what we had here was that this 2 cos, what's our theta? Theta is pi by 6. Pi by 6 plus cos, we have already written cos, okay? We have already written cos, now we're going to write the sine, okay? Okay, so plus iota sine pi by 6, okay? Let's put them in bracket. So, this is how we got our answer. Okay, is this clear? According to the formula, I wrote it just according to the formula. I'm saying it a formula so that we can remember it. Okay? So we'll just forget about it, even if it's a formula. So I'm not going to actually present it that much. So what we can see here is that z is equal to, so we've written it in the polar form, and that's it, nothing else. Okay? And all about those things, which I discussed related to this thing, we'll be discussing about them in later, okay? Okay? So let's forget about all these things. So the question was kind of easy because we already discussed the polar form. So there was just some little things, which were related to the argument, the principal argument of complex number. But don't worry, we're going to discuss it soon. So thanks for watching, and have a great day.